what the AMA stands for.
Yeah. What's your name?
Julie?
Julie. Yeah.
Based on something I thought about was something like right to work laws, where licensure restricts people who could be different services and doing that particular services.
Yeah, so unionization. Yeah, what's your name? You told me before, didn't you?
Yeah, Jason.
Jason?
Case.
Jason. Okay. Yeah.
So in the case of drugs, for instance, that they have a separate entity that is not related to the ones that actually produce the licensure drug.
Like the FDA.
Yeah. Would it be similar to the case where he was explaining that there was another entity that would regulate doctors?
Yeah.
And in that case, it's not completely efficient. Like the FDA still have a lot of power to do that right now. So how would you? I understand like how that would be completely effective, seeing as there's a similar situation in this field that.
Well, I mean, my guess is that my general view is that the FDA works pretty darn well, actually. I mean, it's got its problems. There's things that it doesn't let through that it should let through. There's things that, et cetera, et cetera. But any agency's going to have those problems, and it's sort of impossible to know which drugs are going to work well and which aren't going to work ex ante. But I don't think there's sort of like a giant systematic, distortion coming out of the FDA. And I think without it, there would be a lot of chaos. So I think the FDA is actually a pretty interesting example of things that have worked pretty well. And the FDA is actually largely opposed by much of the industry, which I think is already a pretty good indicator that it's probably mostly looking out for consumer rather than producer interest. So I think that that's an interesting sort of counter-argument to Friedman. Why couldn't something work like the FDA? I think my guess is that an important reason why that's the case is because licensing people is different than licensing products, right? Because people invest all this time to become a doctor, and now they want to protect that, right? Whereas a product, people invest a bunch into trying to get it into the market, and so the main people lobbying in favor of it are the people who want to get products into the market, rather than people who've already made a big investment. And most of the new drugs coming in, approved by the FDA, are not competitors for old products, but are sort of opening up new categories. And so sort of the dynamics of how that works is a bit different than how the labor market works. So I think often product market regulation are harder to have this sort of capture than our market regulations on the labor market. What's your name? Yeah.
I guess another thing you could think of is social mobility, because it's a lot easier for the wealthy people to maintain their status for their children, because they have a lot of resources to go to universities and college and medical school and professional school.
Yeah, I think that sort of goes along similar lines of what I was arguing, is that, the labor markets tend to work differently than product markets because of how hard it is to change from what you are doing right now. So that's just a more long-term version of that, which is that certain social classes of people are already benefiting from this, and so therefore they don't want any change to occur. I think that makes sense. Okay, so I think that this type of reasoning is pretty exciting and powerful, but I think a natural question is whether it's science or whether it's just, any sort of fluffy discussion that we might be having. And that's why I assigned you this reading by Hilary Putnam, which helps you reflect a little bit on what is the nature of science exactly, and how does that relate to what we've been talking about. So Putnam sort of critiques or is in dialogue with three different views of science. And Clementina, do you think you could tell me what are the three sort of views of science that he's sort of discussing or thinking about?
I think she's trying to discuss Popper's view of science.
Yeah.
So it basically states that science is.
Just tell me what the three views are. I'm going to ask someone else about what the different views are. So there's Popper's view. What are the other two? No, that's fine. Does anyone else remember what the other? Yeah.
Verification, falsification, and Kuhn's idea of paradigm.
Yeah. So inductivist. Let's call verification inductivist. Popper. Let's call it Popper. Yeah, that's absolutely right. So can Jordan. Is Jordan here? Jordan Sokolowski? Okay. So, coming to you, why don't you tell me what the inductivist view is?
It was basically saying that science has to be completely accurate, and there can be any mistakes to it. So it has to be absolute in a way, which she talks in detail that can't really be possible because there's no way.
Yeah, so that's sort of a part of the inductivist view. But I think the probably simplest way to describe inductivist view is just what you learned in middle school or like in elementary school when they taught you the scientific method. It's like you come up with a hypothesis. You run an experiment to test the hypothesis. The hypothesis is true or not. If it's true, you like build other implications of that. And then, once you believe in the hypothesis, you use it to go, build a machine or build a factory or, do whatever it is you're going to do with it. Yeah, go ahead.
I think also it includes the idea that past results confirming a general principle can accurately make future predictions.
Yeah.
So that you obtain this law or this idea that things follow a regular pattern into the future, and it's not just confirmation.
That's it. That's sort of the classic. Your name again is
David.
David.
Body.
Body. I think that's exactly the inductivist view. Yeah.
I find an interesting point where it's like that method is basically trying to falsify something rather than justify it, rather than saying by trying to prove it not true and failing, and they're saying that it's true, and rather than just trying to prove it it's true by an isolated way.
Well, I think actually the inductivist, it's Popper who's more along those lines. Just to elaborate on that, Luke, could you tell us briefly? Sorry, your name again is
Max Messier.
what?
Max Messier.
Max. Okay. Max, could you elaborate on what Max said and tell us what Popper's view of science is?
Well, I think Popper's view of science is like it's a little bit more circular, whereas there's not really an a priori principle that governs science, but you learn based off of experience, and by succeeding one time before, the next time you'll be more likely to succeed and you'll kind of know your results.
So I actually think that's a bit closer to Kuhn's view of science in some ways, but so Popper's basic view I think was quite similar to what Max was saying, which is that from any given theory you derive falsifiable predictions if when you actually run the experiment those predictions aren't falsified, then you continue to think about that theory. You don't reject it, but you also don't think it's any more true than you thought it was before. You just don't think it's false. That's Popper's view. Sun Tzu. No one here is doing anything like moderately like that. Sun Tzu, no? Okay. Well, so the third view is Kuhn's view of science. Oh yeah.
I was just going to talk about Popper.
Oh, go ahead.
You more or less said it. I would
Yeah.
say he's basically saying that something cannot be absolutely true. It's just probably less false.
Yeah, sort of. So that's sort of the. But he even would probably not even go that far. He'd just say, well, it didn't turn out to be false, and that's all we can say in some sense. Now, Kuhn's view is very different than either of these. So Kuhn's view is that theories not only are sort of unfalsifiable or unprovable, that science is not really about figuring out whether theories are true at all. Science is about trying to interpret the world given the structure of the theory, right? And trying to solve puzzles. And what's a puzzle? A puzzle is something that a theory finds that if you are thinking in terms of a theory, seems strange, right? And that as a result of this, there's really no criterion for saying this theory is better than another theory. Really, theories are different languages for talking about the world. And sure, certain things can be more awkward to talk about in one language than in another. Anyone who speaks multiple languages probably knows that. But it's not like one language is the wrong language or the right language. It's not really even a very useful way to think about things. That's Kuhn's view. And that scientific revolutions, changes from one view to another, don't happen by people saying, oh, this theory's wrong, let's switch to another theory. Instead, they happen that the old people who believed in the old theory sort of die off, and the young people get converted to the new theory. Why? Because it's sort of more interesting or fun or useful to be using this other theory than it is to be using the old theory. So what Putnam sort of does in this article is he tries to clarify Kuhn's critique of the older views and to try to like come to some understanding between the different views. So Putnam, the first thing Putnam does is sort of dismisses Popper's view versus the inductivist entirely. So he just says that it's absurd to think that all that we're doing is like testing a theory, and then if it doesn't fail to test, we're continuing to test the theory. Because what do we actually use science for? You use it to make medicines, you use it to make ships, you use it to make compasses, you use it to like, build nuclear bombs. And like, not like the goal of science is ever just to go on the process of testing science. We almost always end up applying the ideas we get out, and therefore the things that survive the test are things we come to believe in more, not just to know haven't been falsified in the past, right? But his primary critique is not of Popper versus the inductivist, but rather of the inductivist and Popper together in the spirit that Kuhn was following. So in particular, he says that even the most famous, even the best, even the theories you've been learning since you were a little kid, don't imply anything directly about the world which could be tested. So that's a very strong claim. And as an example of that, he gives Newton's principle of universal gravitation. So, Michael Weyl, could you explain why Putnam thinks that universal gravitation makes absolutely no predictions about the world?
I'm not sure if I can. I'll try.
Yeah.
So essentially, Hilliard was talking about how the universal law of gravitation wasn't just like everything behind the universal law of gravitation wasn't just derived by Newton. Like Newton didn't derive like Kepler's laws or whatever.
Mm-hmm.
So to say that Newton's law of universal gravitation stands in itself as a theory to explain everything is doesn't work.
Yeah, so exactly how it runs. So I think the way that his analysis roughly runs is that if you think about what are the things that we think of universal gravitation as predicting or telling us about the world. Probably the most famous is it predicts the way that the Earth should orbit around the sun, for example, right? That's sort of, if you think about what is the most famous scientific result, most foundational basic sort of scientific result, it's the idea of predicting how the Earth orbits around the sun. But what Newton pointed out is that that prediction does not come from universal gravitation. It comes from universal gravitation under the following three completely false assumptions. So one is that the only things that exist in the universe are the Earth and the sun. Two, that space is a complete vacuum. And three, that there are no forces acting on the Earth and the sun other than gravitation, right? Those may all be sort of like somewhat reasonable approximations, or may turn out to be somewhat reasonable approximations, but they're certainly not like part of the theory. They're like not only sort of very specific assumptions about the way the world actually is, but they're completely false assumptions about the way the world actually is in addition to that. So the point is that, once we've made those assumptions, any test to see whether the Earth actually does go around the sun that way can't be interpreted as a test of gravitation. Because if it were rejected, you would almost certainly come to the conclusion not that gravitation was false, but rather that, in fact, there's other planets other than the Earth and the sun. And that, space isn't a complete vacuum. Or that, there's important electrical forces between the Earth and the sun as well. Or something of that sort. And in fact, that's what always does happen in practice. So, when they were trying to study the orbit of Uranus during the 18th century, they noticed that Uranus didn't follow the path that we would think it would follow based on the planets that already existed. And what did people say then? Did they say, universal gravitation's false, let's find another theory? No, they said there must be another planet that we're not thinking about. And that's exactly how they discovered Neptune, right? And then they made predictions about what Neptune's orbit should be, and then they looked for something in the sky that might be Neptune. But the point is that's a completely different approach than the other one. And in fact, the way that Einstein